Mr. Sally was starting on an example. It was left behind because most of you were leaving the room. So I'm going to start from that question. I'm going to share the document, pick up that question. It is in your notes, and then we proceed from there. We are looking at question 3. I hope those who copy that question, that's the question we are going to try to answer. Okay? Can you hear me?
Yes,
Yes.
Yes, teacher.
Okay. So with that question in mind, I'm first going to draw it on the board, then we answer it.
Morning, teacher Elsa.
Morning, how are you?
Actually, good afternoon.
Actually, this afternoon, you're also confused. So it is afternoon. Let me see, what do I have? I have a 10 student course.
Teacher, I'm not hearing anything.
So I hope you can see the board question. The question has been question 3. We are looking at question 3. And I hope you can see the board. You can face the window for my window and look at the question. Now, simply put here the diagram for the window, put it back so that we can discuss how to handle this question. Asking, is Petra there? Petra? Petra, are you listening? Yeah? Nothing. No reaction from Petra. Who is this one? Daisy Natalie. Can you unmute and read for us question 3? Okay. Agatha Kukunda, can you read the question? Girls, you're not responding. What is happening? Huh? I want somebody whose arm is up. Today, I'm not with very many teachers here. I'm requesting somebody to read for us that question which Mr. Sally was starting on, and we move on.
Diagram shows a uniform.
One person. Now that we leave that reading to one person.
The diagram shows a uniform bar of weight 0.8 newtons resting on pegs A and B. Find the reaction at each peg.
So we are finding the reaction at each peg, okay? The reaction at each peg is drawn at the points of support. So there is that reaction, and okay, I'm going to remove that. That reaction there, we shall call it reaction A. And there is another reaction here at this peg. That's the second point of support. Okay? That reaction there is labeled as RB. I hope you can see the values out together. The reaction where they are being drawn. Those are the direction of the reactions.
Yes.
Here. Okay. Now let us try to establish the length of this what is it called? The length of this bar. Okay? So if we call this the 0 point, this is the 10 centimeter mark. Now, where is the weight acting? Can you tell me where the weight will be acting? The weight will be acting at the 50 centimeter mark, somewhere in the middle here. At that point there, we shall have the 50 centimeter. Is that okay? Is that okay?
Yes.
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 How long is, so here I'll put a weight. W, it has been given as 0.8 newtons. I know this length here is 100 centimeters. That's what I know. So I know that the length of this bar is 100 centimeters. Now from here to here, what centimeter mark is this one?
20 centimeters.
No,
20 centimeters.
the 80 centimeter mark. So I am labeling it. It is easier for me to label it like that. Okay? Was there any other distance that was given? There was a distance given between the pegs. What is the distance between the pegs? Is it whatever?
50 centimeters.
It was 50. That distance there was given. That's 50. 50 centimeters. So let me read this. If this is 20 plus 50, how many centimeters are those? Those are 70, isn't it?
Yes.
This peg is not only 100. Let me see. I have added 10. This is 80. This is 80. 80 subtract away 50. What does that mark become?
30.
Become the 30 centimeter mark. So what is this distance here? So what is the distance of the 10 Newton weight from this
10
here?
20.
It's 20. Is that okay? So this distance here, when calculated, it will be 20. So please make note of those in your calculations. Okay. I'm going to be using the formula. I'm going to take moments about point B.
Excuse
Please mute. Marusha, Mary Anna, please mute.
I want to take moments about support B. Support B here. So tell me what will happen as far as what will happen, what direction will this be? Ignore all. This is our support here. I hope you can see the support. That is our support here. That is our support. That is our people here. Suppose I take moments about point B. What moment will this be? The 10 Newton. Will it be clockwise or anti-clockwise?
Anti-clockwise.
It will be going down. That's the direction. Okay? Now, suppose that is again my pivot. What direction will be the direction of the arrow? Reaction A. It will be upwards like that. And what direction is that?
Clockwise.
Clockwise. This is ACM. And then I go to this one. What direction will it be?
Anti-clockwise.
Down there. Is that okay? So this is ACM. We go to this one. The next force is located at the pivot. Do we take a moment at the pivot?
No.
Why?
Yeah, so.
Why do we ignore this moment here?
Because
0.
Its distance from the pivot is 0. Thank you very much. Then we go to this force here. What will be the direction of its moment?
Downward.
Is that okay? What is that direction? Clockwise and clockwise?
clockwise.
It's clockwise. Okay? Okay, now next remember we say what we apply, which principle are we applying?
Sum of clockwise moments is equal to sum of anti-clockwise moments.
Clockwise moments
Is equal to sum
is equal to
anti-clockwise.
sum of
Anti-clockwise
clockwise moments.
Excuse me, teacher.
Yes, please.
Teacher, could you please repeat how you got 20 centimeters and 30 centimeters for a distance between pivot A and the 10 Newton force?
Anyway, that 20 centimeter, I'm realizing it is not going to be relevant, but this is what I did. I assumed this to be 0, that is 0. So this will be the 10 centimeter mark. Is that okay?
Yes, teacher.
Then to the 10 centimeters, I added 70. And I got
80 centimeters.
And then to the 80, I added 20 to get
100.
Now, from this point here, this is what?
80 centimeters.
80. This distance here is what?
50 centimeters.
So I got this 80, I subtracted away 50. And what point do I get?
30 centimeters.
So having got the 30 centimeter mark, I subtracted out 10, and the distance there will be.
When you chat about how for the 30, why is it on that?
Yeah?
The 30 between.
How I got the 30?
Not sure I've understood how you got it, but for the solution in the question that the note you've shared,
Yes.
the 30 is the distance between the pivot B and the wall.
Let us work out from what I'm presenting here. Forget the solution. Let us work from here. Let us work together because you'll get a better understanding. Can you work with me now? Because I'm taking moments about support B. This is my pivot now. So can we concentrate on what I put on the board and we see whether the answers will agree or not? Because that answer maybe there was a mistake in it. I don't know. So let us understand what I'm talking about first, and then we shall compare answers. Clear?
A times 50.
Okay. So I'm taking the sum of the clockwise moments. Which are the clockwise moments? The first one that we saw was this one, and that one, isn't it? So the first anti-clockwise moment we saw was RA. And what is its distance from the pivot?
50 centimeters.
50 centimeters. Thank you very much. Then what is our next clockwise moment?
6 Newton.
Is 6 newtons. How far is it from the pivot?
6 Newtons
20
times
centimeters.
20 centimeters.
20. So we have that.
20
This is going to be equal
centimeters.
to. Now we are moving to the clockwise moments. At clockwise moments, I start with the
10 Newtons.
10. I'm applying by what?
70.
70. Good. Then plus
0.8.
0.8. I'm applying with what distance?
30.
30. Thank you, girls, because you have enabled me to find that distance is 30. It is 80 subtract 50. So that is 30. Any other moment? Do you have another moment? I think those are the only moments we have. Okay.
Yeah,
So we
only one.
evaluate. What does this give us? Do you see this part of the board?
Yes.
So what do I write?
RA
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 plus 120.
120 is equal to
700
plus
plus 20.
plus
24.
24. Very good. I don't think you can see beyond that. We go to the next part of the board. Can we see here?
Yes.
Okay, so what do I have?
50R
is equal to
724
plus 120
Plus? Is it plus?
minus 120. 50 RA is equal to
600.
Is that okay?
yes.
RA is equal to
12.08 Newton.
and RA is it?
12.08
12.08.
Newton.
That's our value. Is it the same value that you have in your notes?
Yes.
That is it. Very good. Now we want to find RB. So what condition we apply?
Sum of
forces acting in one direction
one direction is equal to sum of forces acting in the opposite direction.
Acting
In one direction
in one direction.
is equal to sum of forces acting in the opposite direction.
Sum of
Forces acting in the opposite direction.
acting in
In the opposite direction.
Okay. So what forces do we have here? So I'm going to consider up
RA plus RB
plus RB
plus RB
Equal to
and down
to 10
is equal to 10 plus
10 plus
is equal to
0.8
10 plus 0.8
plus 6 plus 6.
plus 6.
So we can't see beyond that.
We cannot see beyond that. Okay, so what do I erase?
we have A. Now since we have RA, we substitute.
Since you have RA,
Since we found A, we have
12.08.
here?
we have RB is equal
Can you see
to
here?
Yes. We see like
RA, I substitute RA as
12.08
plus
RB
is equal to
plus RB is equal to
is equal to
16.0.8.
16.8.
RB
We can't see
We can't
properly.
see beyond that. And that
Which is equal to
Can you see that now?
yes.
yes, 16.8 minus 12.08.
What do we get?
12.8.
RB is equal to 1.722. 1.72.
Is it 1?
1.72.
Yes.
Yes.
1.722. Why do I disagree with you?
You can even check a calculator.
4.7.
It's 4.72.
4.72.
It's 4.72.
I think that's the correct answer.
Yes.
Yes.
16.8 subtract 12.04. I think I get 4.72 newtons.
Yeah.
So I don't know whether those answers agree.
Their answers.
Someone said they have the answers in the notebook, in the notes already. Are those the correct answers?
The notes had 1.72.
So please correct, that was an error. It should be 4.72.
Okay.
So that is a question that requires reactions. I hope it has been, I don't know whether anybody has questions.
Yes, teacher.
Yes, please, the questions now.
Teacher, how have we known that to find R, we have to use sum of upward forces equal to sum of downward forces? And find R, we have to use anti-clockwise moments is equal to clockwise moments.
How do we know that?
Yes, teacher.
Anybody who can help me remind how we know that? Please help me remember, how do we know that those are the two equations that the two conditions we are going to use in this example? How do we know that?
That one, I know that they are the ones we have to use, but how do you know when to use which one?
I have to use both of them.
Just so you can use any to find any.
No.
So how
deliberately, listen very carefully. I have deliberately decided to listen. I know I have two unknowns. Do you realize that I have two unknowns?
Yes.
Which are the unknowns?
RA and
RA and RB. Now those unknowns, both of them act at a certain point, and those are the pivots. Is that okay?
yes.
So I know that if a force is located at the pivot, its moment at the pivot, what is its moment at the pivot? Zero. That's why I have selected that when I'm using the equation of taking moments, I must take a moment at one of the pivots. And the most friendly pivot in that arrangement was pivot B.
But teacher, any of them can
How
work.
did you know?
Any of them can work. Actually, any point can work. So the selection of the turning point is very crucial to ease the work that you're going to carry through. Otherwise, I can do this very example using another point. Can I use another point?
Yes, teacher.
Before you use another point,
Yes, teacher,
what
yes.
do you
No, because the principle of moment states that, you state the principle of moments.
The principle of moment states that
yes, state it properly.
When a body is in equilibrium, who is that? Teacher, when a body is in equilibrium, it's the sum of anti-clock of moments acting in one direction at one point is equal to the sum of
about any. Don't misread about any.
About any point is equal to the sum of moments acting in a different direction about the same point.
Not different, you are paraphrasing the principle. And the moment you, listen very carefully, that is a principle. The moment you substitute any word and it doesn't make sense, you have killed the principle. So make sure that the words you are substituting don't distort the principle. So that's why I'm trying to say, read that principle carefully. It will direct you on what you are doing. So can you have a second go at it?
The sum of moments acting in one direction.
Somebody read that principle properly. She's distorting it, the whole of it. So read the principle properly.
When a body is in equilibrium.
One person. Yes, please. I am alone today in this class, so I don't have controllers. So control yourselves. One person.
When a body is in
the moment you have had somebody has gone before you, please, you just stop. So I have had one person go.
Okay. When a body is in
I'm going to get a
under the action of
forces. To you. No, listen, girls. This is what I'm going to do. Who do you trust to be a form captain? Somebody.
Me.
I'm selecting Fiona.
Teacher, who is Fiona?
Kayla. There is no one called Fiona.
Can be the class.
How come I had that one? Okay,
Fiona.
Selecting
Deborah.
Deborah, that's the name that I've had. Deborah, have you heard?
Teacher, democracy.
Democracy is not working here. Deborah, where's Deborah? Now you're wasting time.
Can you please listen to the teacher? Guys, let's listen first.
Auntie, that's what happens. You lose time, you waste everything when you start becoming like that. And for me, I always just withdraw. Okay, please, I'm selecting one person to give us a name of the person who is reading. Who is reading for us? Form captain, select a name. Deborah is selected as form captain. Give me a name and you tell us this person to read the principal moment.
Am I the only Deborah?
Yes, you are the only one. Now listen to these people. Again, time wasters. I want select somebody to read for us the principle of moments.
Now I said Denise.
Denise, do the needful quickly.
Okay, teacher, can you hear me?
Yes, please.
The principle of moment states that when a body is in equilibrium and an action of forces, the sum of clockwise moments about any point is equal to the sum of anti-clockwise moments about the same point.
Now, the most important thing about that statement is about any point. Have they stated the point? Girls now asking a question. Has the point been stated?
Yes.
What is it? You tell me that about the point.
Point B.
Any point.
It is any point. So it is up to you to select that point. That's why I selected it, that here in this question, I'm going to be taking moments about support B. I'm the one who selected the point. So you can select any other point. That's what I want us to do. Can we select another point? Deborah, select a point. other than B? You are selecting which point? Deborah, I'm requesting you to select a point. Select any other point other than B, and we do the number again. We see whether we shall get the same answers.
A.
A. You are timid, Deborah. Deborah, I'm going to demote you. I have a timid form captain. We are selecting moments about what?
Point A.
Point
I
A.
hope you can see the board.
A.
About point A. Now let us go and change everything if our moments are about point A. Okay, so I'm changing these directions here. The rest we have done. We are taking moments about point A. Okay, we start with the 10. What will be the direction?
It will move downwards.
We go down. Okay? We go to R about A. Will it have a moment?
No.
No.
No. Why? You tell me the reason.
It's at the pivot.
It's at the pivot. The moment it is at the pivot, no, the moment is 0. We go to this one. Where will it go?
Down.
Clockwise.
Clockwise.
That direction. Is that okay? Now we go to this
Yes.
one. Where will it go?
Anti-clockwise.
Clockwise.
Anti-clockwise. Anti-clockwise.
Anti-clockwise.
Now we go to this one. Where will it go?
Clockwise. Clockwise.
So moments about point A. Now we substitute. What do we have? We start with the clock. This one. Was it clockwise?
Yes.
Yes,
Right.
it's clockwise.
Right?
10 times 20.
This is not clockwise.
Anti-clockwise.
It's anti-clockwise.
Okay. So this is the first clockwise. So we write 0.8. What is its distance from here? Remember, this is 50, this is 30. So what is that?
20.
20. Good. Okay. We move to this one. Is it clockwise or anti-clockwise?
Anti-clockwise.
So we go to this one. So plus 6 times, what is its distance?
No.
That is
No.
70 plus
90. It's 90.
90. Is that okay?
Yes.
Okay. Now we go to the anti-clockwise, one that we have been lowered. Which one? The first one was 10.
10 times 20.
10 times 20.
20. Is that okay? Then the next one will be
A.
0.8.
RB times
Times 70.
times 70. Is that okay?
Yes.
So now what we have?
70.
I think it's 50 for RB.
It's times 50.
It's 50 for
16.
RB.
Times
16.
not 7.
16 plus.
Be from this one.
RB is 50.
It's 50.
Let them look at your diagram. RB is 50. Thank you.
It's 50.
So what do we have?
16. 16
Plus
540
is equal to
200
100 plus RB.
plus 50 RB.
Okay. So what do we have?
556.
556 subtract
200 got 50 RB.
Is that okay?
Yes.
356.
356 is equal to 50 RB.
Divide by 50 got RB.
What is
B is equal
RB?
to
7.1. 7.12.
We have missed something. Something is not correct.
Something supposed to be 6 times 7.
The problem is
Let me
where
see the distances. The distances are the distances correct.
6 newtons times 9 is supposed to be
6 times 7.
no.
Yeah.
No.
It's supposed to be 6 times 70.
6 times 7.
No.
70.
Supposed to be
No.
70.
It's at the end at the
RB
bottom.
times
Correct.
70.
50 plus
No.
20 gives you 70.
No,
50
it's
plus, yes,
still
it's supposed to be
Yes, 50
20.
plus 20 is
RB,
70.
Because
Then
from
it's
the pivot,
RB from A. It is from the pivot. That is 50.
Yes,
That is correct.
Plus 20.
that's 20, which
This
is
one from there, that is
It's
90. That is
70.
correct.
That's 9.
Huh?
no,
There's a distance which is not correct.
it's supposed to be 70.
70.
So it can't be 90 when the other
For
is 50.
RB.
20 plus 20.
No, wait a bit.
Teacher, yes.
70.
Yeah, look at the pivot A and you measure those.
70 was
20
beyond
plus
A.
20.
No, 70 was beyond. Let me see. The
Yes,
distance
it was
between
below.
the distance between the pivots is 50. It is the one that below. You see what I'm doing with the
Yes,
diagram?
50.
Yes.
50 plus
Yes.
20.
No. The distance which I have failed. Listen, the distance which I have failed is this distance here. A 6 Newton force is the one that I have failed. This distance
Supposed to
here.
be 70.
Listen, this distance here. It's 100. You see this 100 centimeter mark? Because the 70 goes beyond it.
Yeah.
Is that okay? I should be using the 100 subtract out the 30. So what this distance here should not be 90.
Yes.
It should be 70.
70.
Oh.
That's the
20
distance that I
plus 30
failed.
plus 20.
That distance, please, I failed it. It should be 70. So what do I get?
Ah.
Six times 70 gives me 420.
20.
Okay. So when I add the 2, I get 400. So what? 436. Is that okay?
Yes.
Yes.
Oh,
So 436 gives me, when I take out 200, it gives me
No. That would be 236.
336 teacher.
So when you divide 236 by 50, what do you get?
4.72.
4.72.
4.72.
Is that the same answer we had previously?
Yes. Yes, it is.
Now, what do we apply?
Sum of forces in one direction is equal to sum of forces acting in the other direction, the opposite direction.
Equal to?
Sum of forces acting in the opposite direction.
Good. So I'll have my RA plus my RB.
RB is equal to
10
plus 0.8 plus 6.
Okay. So this will be
RA plus 4.72 is equal to
16.8.
And what is RA?
RA 16.8
is 4.08 Newton. Teacher, we can't see.
You can't see.
12.0.
The answer is 4 point.
Which is equal to 12.08 Newton.
Now, can you see?
Yes.
Yes.
So what is the answer?
Yeah.
12.08
Newton.
12.08 newtons.
Okay. So what have we discovered? Moments can be taken about any suitable point. The moment you are correct with your conditions, you always get the same answers.
Yes.
So for convenience, we always select the pivots. But somebody who is adventurous can even select the point 0 and put the moment there, because the statement reads moments taken at any point. So the selection of the pivot is up to you. The most important thing, obey the rules that follow. Is that clear, girls?
Yes, it is.
Yes.
So I want us to emphasize, I told you that the only challenge with the moments, usually the questions are a little bit tricky. So we need emphasis for some of these questions. Clear?
Yeah.
Yes.
Let me see what is available in our notes.
No.
Teacher,
Yes, please.
did the question have any mistake?
The question did not have a mistake. It is the final answer which had a mistake of this one. It is supposed to be 4.
Okay.
There's no mistake in the question. Yeah? This question here, where you have a 1, it is what?
16.8.
Yeah? You correct that answer which I have highlighted as blue. That's the only wrong answer. It's supposed to be 4.72. Do you see the notes where I'm highlighting? You correct that answer from 1 and put there a 4. That's the mistake that you have. Are we okay?
Yes, we are.
I'm trying to select a question that is also challenging. I want us to look at this question that don't have solutions now. Okay? Yes. I'm looking at question 6.
What about 5?
What about 5?
You want us to go through 5?
Yes.
Okay, let us start from 5.
Both.
All of them.
They give you a question of redrawing the diagram also.
Yes, that's why we have those questions there. Okay, I'm going to look at 4 because I think let's start at 5. I think most of you have 4. Let's look at question 5. Yes. So question 5, Deborah, are you still in charge?
Yes, teacher. Sorry, my network is a bit shaky.
So tell us somebody, give us somebody to read.
Cynthia, Sarah.
A uniform meter rule is balanced at the 20 centimeter mark. By a mass of 240 grams placed at one end. Draw a diagram to show the state of balance of the meter rule.
The uniform meter rule is balanced. At the 20 centimeter mark. So we have 0. We have the 20 centimeter mark. How long is the meter rule? A meter rule is usually 100 centimeters. Is that okay? Yes. Since it is uniform, where do we expect its weight to be active?
At 50 centimeters.
So at 50 centimeters, we have a weight. At 20 centimeters, we have a pivot. Remember, this diagram was not supposed to be there. You are supposed to draw it. Is that okay? At 20 centimeters, you have a pivot. Then at one end, you place a 20 gram mass. Yeah?
240.
Oh, 240 grams.
240
Now, where
grams.
would you place the mass? Would you place it this side or this side? Would you place it at the 0 mark or the 100 centimeter mark? By the position of the weight and the pivot. Where would you place it?
Zero mark.
At the 0 mark. Automatically, you will place it at the 0 mark. Is that okay? This is
Yes.
240 grams. Is that okay? But we want to get this force here. This force here is given by mass times
Gravitational.
So what is our mass?
2.4 Newton.
240.
Teacher, we cannot see where
This
you're
is outside
writing.
of the blackboard. So we can't see there.
0.24.
So now we can see.
Okay. Times what?
Times 10. Times
How
10.
are we finding?
What we get?
2.4 newtons.
2.4 newtons. Is that okay? So our F here is 2.4
Yes.
newtons.
Newtons.
Okay. What are they asking us to find?
The weight and mass.
The weight and the mass of the material.
So what do we do?
Excuse me, teacher.
Yes, please. Yes, please.
Teacher, how come we place the force at the 0 centimeter mark and not the? Anyway, it's okay. Teacher, it's okay.
What is okay?
Because on the other side, there's another.
Have you got that point?
The
The forces must be on
Teacher,
opposite
yes,
side. The forces must be on opposite side of the pivot. I hope that is what is okay.
Yes.
Yes, teacher.
So we are taking moments about the pivot. So we have some of
Clockwise moment. Because some of anti-clockwise moment.
Anti-clockwise moment.
The sum of anti-clockwise moment.
So we see that direction and this direction. So what are the clockwise moments? By the way, did you get the distances?
Yes.
What are the distances?
20.
20. And then
30.
30.
And the other is 50.
Okay. So the moment
2.4 times 20.
W
which is
times
clockwise
30.
moment.
W.
The clockwise moment. We have written down for clockwise moment.
W.
24 newtons.
W.
24 newtons.
W times
30 is equal to 2.4 times 20.
times 20. Good. So we have 30. W which is equal to
Is equal to 48.
48 only.
Yes.
And then what is our W?
1.6.
1.6.
1.6.
1.66.
1.6.
So how do you convert that to them? Because they're asking us for mass.
Weight is equal to mg.
Weight is equal to
Weight is equal to mg.
weight
is equal
is
to
equal to
mg.
mg.
1.6 is equal to m times 10.
And
1.6
is equal to
is
m
equal to m times 10.
which is it? Which is
0.6 divided by 10 is equal to 10
Ma.
m divided by 10.
0.16.
and what is the unit?
M is equal to 0.1.
Kg.
Kilogram.
And what is grams? What would it be in grams?
0.1.
What is it mass in grams?
1,000.
160.
I'm referring that answer to be in grams because the mass that was given was originally in grams. Is that okay? So it would be wiser to take this answer either I think it should be in grams so that it becomes
Okay.
okay. So I hope you have got the point, but when it left it here, I don't think we keep it line. Okay? 0.16 kilograms. As long as you have the correct unit, you are still correct. Is that okay? So no question, I think. Question 5, we are done with question 5. We go to question 6. Remember that we don't have answers, so I hope people are not asking you that they should write. Fill in. Fill in quickly. I'm giving you.
I'm confused.
Yes. Somebody is confused. Let's unconfuse her.
About 1.6. The 1.6 is equal to m times 10. Where did the 10 go? I thought it was supposed to be 10. M is equal to 16 out of 10.
We did 1.6 divided by 10.
You divide 10 on both sides.
Without getting the 16 divided by 10 times 1 out of 10. We just did it all at once without expanding it.
Has your question been answered? I don't know. Has the question been answered? Because we're offering options of handling that and they are all correct. We divide both sides by 10. So can we move? Okay, we are ready to move to the next question?
Yes. Yeah.
Okay. Thank you. So Deborah, again, select a reader. We are now discussing the question 6.
Still assigned.
Salim, I had Salim.
The figure below shows a uniform metallic meter rule balanced when pivoted. The figure below shows a uniform meter rule balanced when pivoted at the 30 centimeter mark under the conditions shown in the diagram.
Uniform meter rule starts at 0, ends at 100, and at 50 something as happens there. It is balanced at the 30 centimeter mark. And there are forces of That's 4.5 and what? Okay.
4.8. Take 4.8.
4.8. It acts at what centimeter mark? Read for me. The first one
At the
is
10 centimeter
10
mark.
centimeter mark.
10
then
centimeter
there's
mark.
another one. Where
And
is
then
it?
W is at 50 centimeters.
There is W.
Yes.
Then there's another one at what centimeter
0.5 is at 70 centimeter mark.
0.5. That mark, okay? Then
Yes.
next, what are we doing? What are we supposed to find?
We are calculating the weight of the meter rule.
You have to find the distances between them.
So let us find these distances. We are finding distances from the pivot. So what is that distance?
20.
Then what is this distance here?
20.
It's also
20.
centimeters. Then we have this distance here.
40.
40.
How does all that refine? Is that okay?
Yes.
So what we do? We take
Moments at the pivot. About the pivot.
About the pivot or clockwise moment. This was some of anti-clockwise moments.
So we identify our moments. This one will be that way. This one will be that way. This one is that way. So this is the ACM. This is CM. This is CM. Okay. So the clockwise moment.
W times 20.
Times 20.
0 plus 0.5 times 40. 40.
Is equal
Which is equal to 4.8 times 20.
4.8 times
20.
20.
20. Remember why we are not changing the units for distance. What's the reason?
So cancel itself out.
They'll cancel themselves out. Very good. So we have 20W and this one
20 plus 20.
is it 20?
Yes.
Yes, plus 20 is equal to
96.
96.
Yes.
Okay. So 20W is equal to
96 minus 20. 20W is equal to 76.
what is W?
3.8.
So W is equal to 76 divided by 20, and you say W is equal to 3.8
newtons.
8 newtons. You cannot see this?
We can. Come on. I can.
Oh, you can.
Yes.
Okay.
Yes.
Was that the first part of the question?
So that's the second part. The first part was to redraw the diagram
Redraw.
showing all forces.
And showing all forces. By the way, there is a force we have not shown. Okay, those are the forces. We are going to take that. Don't they have another part?
No,
They
there's
don't
another
have
part.
another part. Okay, this question doesn't have another part. It is okay.
Yes.
Teacher, in the next time,
But there is another force which I have told you that there is a force we have ignored. Which force is that? You tell me the force that is missing. There's
A
a force
resultant
here.
force.
There's the resultant force.
A
That
reaction force.
there's the reaction force R. Is that okay? There must be that reaction force R. Because the question will continue and ask us to find the reaction. Is that okay? So when they say indicating all the forces, we must put that force there. I don't read that question. So that force must always be put there because they may also want it. So for our sake, what would be that reaction? Let us just make an addition. Reaction at the pivot, what would it be?
Sum of forces in one direction is equal to sum of forces.
Reaction at pivot would be and there's only one upward force, isn't it?
Yes. 4.8. 4.8 plus 3.8.
3.8
plus 0.5.
0.5. Very good. What would be that total reaction?
Nine. 9.1. 9.1.
Is it 1.8 or 1.8?
And is it 9.1?
It's 9.1. Thank you. 9.1 Newton Z. That will be the total reaction at the. That will be our reaction at the pivot. Is that okay? So that's what we have.
Yes.
Okay. We are beyond. We are beyond the time. Okay. So
yes, teacher.
Question, we shall talk about it later.
Next week.
It is the last question in our challenges. I hope most of the things have been highlighted as far as the questions we have done. We have taken time on the calculations. I hope people are benefited and they can either be able to handle any question now. So it is only question 7, which is a rare scenario. What is rare about question 7? Somebody read for me just one statement that is not, we have not used yet.
A non-uniform
blank. Is that okay? What will that tell you if it is non-uniform?
The
center of gravity is not in the middle. Thank you so much, girls. Have a lovely day. Being the only one in the house. The other teachers say meetings. Going to rotate, so you can also go and rotate. Lovely weekend.
You too. Thank you.